Hi guys, I'll continuing our theme of writing recurring decimals as fractions. Like to start off with a simple one that you all know, and that is 0.3 recurring. Now I'm going to say that x is 0.3 recurring. I'm going to write it 0.33333. And I'm going to say that if I times that by 10 to get 10x, that moves the decimal point one place to there. So that's going to be 3.33333, etc. And now you can see that these bits here are the same. Now, what that means is that when I subtract 10x, take away 1x, I get 3.3 recurring, take away 0.3 recurring, so I just get 3. And 10x, take away 1x gives me 9x, is 3. And if I divide both sides by 9, I get x is equal to 3/9, which is equal to 1/3. Now, I can do similar with other ones. So if I went for, let's put it 0.7 recurring, so x is 0.777, etc. So 10x is 7.777, etc. So if I do 10x, take away an x, because the decimals are exactly the same on these, I get just 7. So 9x equals 7, because 10x take away 1x is 9x's. Divide both sides by 9 and get x equals 7/9. Now if I had a slightly different one, so say I went for 0.36 recurring, and what that means is my x would be 0.363636, etc. So my 10x would be 3.6363363, etc. Now, I can't use that because the decimals are different. This one goes 3636, this one goes 6363. Completely different decimals, so I can't use that to do my subtraction. But if I times by 10 again and got 100x, that would give me 36.363636. And now you can see that these decimal bits are exactly the same. So I can do 100x take away 1x, and a 36 take away 0, decimal points will disappear, is 36. So 99x is equal to 36. And if I come up the top over there, that gives me x is equal to 36/99. And you should notice that they're both in the 9 times table. So dividing them both by 9, I get 4/11. So just one final example. Let's have a look at 0.431 recurring. So that would be x is 0.431431, etc. If I times by 10, I would get a 4 point, and then it would be 314314. So that's not going to be any good. If I times by 100, I would get 43.143. Well, 143 is not the same as 431. So I need to times actually by 1,000. And that would give me 431.431431. And you can see that's achieved our goal of getting these decimals the same. So now when I do the subtraction, 1000x take away an x, that gives me 431, take away 0, the decimals disappear, 431. So that means I'll have 999 equals 431, and so 999x, so x is equal to 431 over 999. Does that cancel down? Well, let's have a think. 999 is 111 times 9, which is something times 3. What is it times 3? 37 times 3. So it ends up being 199 is 37 times 3 times 3 times 3. Now does 431 divide by 3? Well, I would these digits would have to add up to a multiple of 3, or 4 add 3 add 1 doesn't. Adds up to 4. Is it a multiple of 37? It's getting close, but it would be close to 37 times 11. What's 37 times 11? Maybe 37 times 13, because it would have to add a 1 on the end. I wonder what 37 times 13 is. Anyway, let's just see. Does 431 divided by 37? No. Let's go for, if I put this in as a fraction, 431 over 999. If that cancels down, that'll automatically change it, and it doesn't. So that just leave there. So that was just me thinking, does that cancel down? So our initial thing is, let's get the decimal points being the same. So for this first one, if I times by 10, the decimal things were the same, so I could subtract them and the decimals would disappear. This one, times it by 10, gave me all 7s. Subtracting them, the 7s all disappeared, just leaving me with 7 take 0. Here I had to times it by 10, changed the decimal. It wasn't 3636, it became 63. Well, that's different. But times it by 100, brought that back again. So I had to do the 100x, take away the x, to make the decimals disappear. And here I had to times by 1,000 to make the decimals disappear. So I was doing 1,000x, take away x is the same as 431, take away 0. And don't forget, you can always use your calculator at the end to see if it cancels down. Okay, so there'll be a second lesson on that coming up next time when we do some slightly trickier ones. Okay, thank you.